So welcome to all of you. So today we will go to the last chapter of this multivariable calculus, that is multiple integral. So in the last 2 years or last 3 years, that is from 12th and FY 11th also, you have seen single integral, that is the integration of the function of a single variable. Okay. So all the formulas are same. We have to apply all the formulae here also. But here what, there are double integral, triple integral, right? So only the way of the order is important here. You have to integrate with respect to y, with respect to x. You have to maintain that order of the integration. You have to take only the care of that integration, right? So this is what it is, a double integral, triple integral, but it is very easy, right? It is same as the all the formula you are using as a one variable, right? So that we have seen in the 11th standard, 12th standard. The same formula you are using here, right? And same thing you are using here. We have to take the care of the variable, right? So to order of the integration now here, right? So what here? So there is a Fabini's theorem. So that Fabini's theorem, this is a statement. This statement is very important, and we are using this to evaluate the integration, double integration or triple integration. Okay. So Fabini's theorem is what? If f is the continuous on the rectangle, this is a rectangle. Okay. So R is what? Set of all order pairs x y such that x lies between a and b. That means x is the closed interval a b and y is the closed interval c d. Then double integral over R, that means this region on the rectangular. Okay. So dA means what? Dx dy. You may write this is what? Dx dy also. Okay. So integration from a to b, c to d, f of x y dy dx. So see, this we are integrating with respect to y first here. So your y is this should be the limit of the y now here. Then you are integrating with respect to x. So this should be the limit of the x. So last one, the first integral is nothing but the limit of the last one. Okay. Now same here, c to d, a to b, f of x y dx dy, because this a and b are the limits of x. So first we are integrating with respect to x now, and after that you are integrating with respect to y. So when you are integrating with respect to x, so you have to take y as a constant here, right? So then you are putting your limit of the x, then your x will be removed, then only the function of y remains, and then you can integrate with respect to y. Okay. So here also same thing here. What you are integrating with respect to y first, that means you have to keep x as a constant, and use your usual formula to integrate that one. So then what, you are putting the limit of y now here. So in the first part, what, your y will be removed, one variable will be removed, then only after putting the limit, say y is equal to c and y is equal to d, so then x will be remain, function of x will be remain, and that you can integrate with respect to x by our usual formula. So you have to use our usual formula here only. So I have to take the care of this one, what, the order of this one. So here what, this is first is what, dy. So that means these are the limits of y. Then you are integrating with respect to x, then these are the limits of x, right? So here what, you should have to integrate with respect to y first here. Okay. So here what, dx dy, that means what, here you must have to integrate with respect to x. So when we are integrating with respect to x, your y should be the constant. Your y is a constant here. Keep y is constant here. Okay. So use our usual formula which I have studied in the 11th and 11th, 12th or last year S.Y.B.Sc also, right? So that we have to apply the formula. Okay. So we'll take the problem so that your idea will be clear now. So you should remember all the formulas which I have studied in the 12th, up to 12th now. All these formulae you have to use. So it is given in the log table also. So just write down all the formulas, okay, and remember that all the formulas, right, and try to apply it. Okay. So we'll take a problem so that your idea will be clear. Evaluate double integral over R x square minus y square dA, where R is equal to set up all points xy such that 0 less than equal to x less than or equal to 2, 1 less than equal to y less than equal to 2. Okay. So now solution. I will write this as I now. Double integral over R x square minus y square. dA means dx dy or dy dx, whatever this. See here, the limits are not mentioned here. You can write here dy dx, dx dy, doesn't matter for this dx. You can write dx dy, dy dx, whatever this. Already is unimportant here. If the limit only we have mentioned here the region only, so this already is unimportant here. But when you are putting the limits of x and y, then the order is dx dy is very important here, right? Okay, so now here what r is the region what directly we are given the rectangle. This is what limit of x is 0 to 2 and limit of y is 4 to 2. So I write this is first limit as the x. So this is what 0 to 1, 0 to 2. Okay, then 1 to 2. This is 1 to 2. Now I have written the limits here now. Okay, so now the order of dx and dy is important. These are the limits, 1 to are the limits of y. So I will write here dy and then I have to write the dx. Okay, so now this is what 0 to 2. I will integrate this, right? Because each term is integrable. Each term is integrable, right? So that means I can integrate this one. Limit of the integration of x square. X square is constant now because we are integrating with respect to y. So x square is constant. You know that the integration of constant is constant times that variable, right? So x square y now. This is what x square y minus y cube upon 3, and the limits of y are 0 to 2. Yes, same as usual now. This is what as you did it all these things. Okay, so now we'll put y is equal to 2 first and then y is equal to 1. Okay, so this is what 0 to 2. I write in curly bracket. Okay, so first I will put 2 now. I put the y is equal to 2 and then I will put y is equal to upper limit and lower limit. So function of I will put upper limit. So this is what twice x square minus, so y is what then 8 by 3. This is 8 by 3 minus, you have to put the lower limit now. Okay, so lower limit is what then x square minus 1 by 3. So now this is the x. Okay, so I will simplify this. Okay, 0 to 2 now. So twice x square minus x square is x square now. This is what x square. Okay, then minus 8 by 3 and this minus become plus 1 by 3. So 8 minus 1. So this is actually what minus 8 plus 1. Minus 8 plus 1 minus 7. Minus 7 by 3. This is what minus 7 by 3 dx. Okay, so now I will integrate this with respect to x as usual now. So this is what x cube by 3 minus 7x by 3 then 0 to 2. Now see here, if you put the lower limit, so each term is 0. So that means what no need to put the lower limit, we'll put only the upper limit and that will be our answer. So this is what minus 14 by 3. So 8 minus 14 is minus 6 upon 3 and this is what minus 3. Okay. Okay, so we'll take the next problem. See, this is very simple. We'll take the next problem. Evaluate double integral over r y into sin xy dA. This is what dA. Okay. So limits are not there. You can write dy dx, no problem. So dA, where r is 1, 2 cross 0 pi. That means this is a rectangle. X is limit of x is what 1 to 2 and limit of y is 0 to pi. Okay, so I will take the solution. Let r is equal to double integral over r y sin of xy. Y sin of xy. Y sin of xy. Okay. dA. This is very important. So your integration must be aided with dx, dy, dA or okay. Now I have to put the limit. So now take the care of the function also. Right? Now see, this is y sin xy. So this, if you want to integrate y sin xy, this is a product of function of y. Right? So if you want to integrate this with respect to y, then you have to use the by part. Right? Now to avoid the part, now this is very easily integrable with respect to x. This is what? Easily integrable with respect to x now, right? So instead of putting the limit of y, integrating with respect to y first, what we will do? We will integrate with respect to x first. So to integrate the function with respect to x, that means first we have to write the limit of the y now. This is what then 0 to pi, right? So then 0 to oh, this is 1 to 2. This is what? 1 to 2. 1 to 2. So y sine of xy, I will integrate dx dy, right? So you can integrate with respect to y also, but here what then 0 to pi, but you have to use the pi part then, right? So the problem will become a lengthy, right? So that I will integrate this with respect to x first. Okay, now 0 to pi, I will integrate this. Integration of sine theta. What is integration of sine x? Integration of sine x. So if you want to integrate within sine x, just ask the function that what, whose the derivative is the sine x, whose derivative is the sine x. So derivative of minus cos x, derivative of minus cos x is a sine x, because derivative of cos x is minus sine x, right? And this is what minus cos x. So derivative of minus cos x is sine x. So integration of sine x is minus cos x. So your y as it is, right? Sine minus cos of. Okay. So this is minus cos of. So I will write the minus sign here now. Minus y cos of xy upon coefficient of y upon coefficient of x. We are integrating with this. So this is y. Now see, the problem becomes very simple, because what? This your y gets cancelled now, right? Okay. So what I will do? I will put x is equal to 2 and I will put y x is equal to 1. Okay. So now this is the product. So y get cancelled here. So this is what is 0 to pi. I will write in single bracket. No, you use to curly bracket because there is a single term. Okay. So just put the upper limit minus the lower limit. So this y get cancelled. So minus cos twice y. Minus cos twice y. Now you are putting the lower limit. You have to subtract that one. So minus of minus cos y. So this becomes plus cos y. Plus cos y dy. Right? This minus minus become plus, because what? This is your minus. Okay. So minus minus become plus. So now we will integrate this now. So this is what? Integration of cos. Integration of cos. So derivative of sine is cos. So this is what? Minus sine of twice y upon 2 plus sine of y. Just sine of y. Okay. Now 0 to pi. 0 to pi. So you know that sine 0 is 0. Sine 1 pi, sine 2 pi, sine 3 pi, they are the 0. So this is what? This is 0. Right? If you put the upper limit, that is also 0, because sine 2 pi is 0, sine pi is also 0. If you put y is equal to 0, then sine 0 is 0, sine 0 is 0, sine 0 is 0. Right? So if you put both the upper limit or lower limit, the value is 0. So your answer is 0. Okay? We'll take the next problem. Evaluate integration 1 to 4, 0 to 2, 6x square y minus twice x dy dx. 1. I will take the second problem also. So minus 3 to 3, 0 to pi by 2, 0 to pi by 2, y plus y square cos x dx dy. Okay, so first we will solve this problem. Okay, solution of 1. Let I is equal to just 1 to 4, 0 to 2, 6x square y minus twice x dy dx. Now first we have to integrate with respect to y, because limits are given. You have to integrate with respect to y, and then we will integrate with respect to x now. So 1 to 4 as it is. I will integrate this. You are integrating with respect to y, so you have to keep x as a constant. Okay, x is constant. So your 6x square is constant. Integration of y is y square by 2. Minus your twice x is constant. So this is what? Twice xy. So you have to put this is what? Limit 0 to 2 dx now. Now see that each term contain y. That means see, if you put a lower limit 0, then not all the terms are 0 now. So no need to put the lower limit here. We are putting only the upper limit only. Okay. So that means what, in one bracket, right? So it is the only single bracket. No need to use the curly bracket. Okay. So that is what this 2 get cancelled. Okay. So all we will put here. What? Y is equal to 2. So 4 upon 2 is 2. So this is what, 12x square. This will be 12x square minus 4x minus 4x dx. If you put the lower limit y is equal to 0, then each term contains y. So therefore what? If you put the lower limit 0, so then all values are 0 now here. So no need to put the lower limit now. Okay. So now we will integrate this now. So this is equal to 1 to 2. No need to take now 1 to 2. We are integrating this because all terms are integrable, right? So this is what, 12 x cube by 3 minus 4 x square by 2. So this is what, 1 to 2. Okay. So just I will simplify this. So this is what, 4x cube minus twice x square, and this is what, 1 to 2. First I will put 2 now here. So 2 cube. Right? So 2 cube is what, 8. So this is what, 32 minus this is what, 2 raised to 2, that is 4. 4 into 2 is 8 minus I put x is equal to 1 here. Then this is what, 4 minus 2. Okay. So this is what, 32 minus 8 is 24. Is 24 minus 2. 4 minus 2 is 2. So this is what, 22. So this is 22 is the answer. Okay. Oh, limit is 1 to 4, not 1 to 2. Limit is 1 to 4. This limit is what? 1 to 4. 1 to 4, not 1 to 2. Okay. So 1 to 4. We have to put 1 to 4 now here. This is 1 to 4. Okay. Now I have to put x is equal to 4 now. So if you put 4 here, this is 4 to the power 4 now. This is what? 4 to the power 4 minus this is 4 square 16. So this is 32 minus this is what? 4 minus 2. Okay. So 4 square minus 30. This is 2. So 34 now. 34 minus 34. 4 to the power 4 is what? Is 224. This is 224. So total answer is here 222. Total answer is 222. Okay. Just check this. Okay. So we'll solve the second one now. We'll solve the second. You have to take the care of the limit now. You have to take the care of the limit. Okay. So now this is I now here. Okay. I. So now here what? Integrating. This is x now. First we have to integrate with respect to x. Then we have to integrate with respect to y. Okay. So your minus 3 as it is. We'll integrate this with respect to x. So note that you are integrating with respect to x. That means you have to keep y as a constant. Okay. So y constant here. So integration of this what? Integration of constant x times that you are constant into that variable plus y square is as it is, and integration of cos x is sin x. Integration of cos x is sin x, 0 to pi by 2 dy. Okay. So now this is equal to minus 3 to 3. Now if you put lower limit now, so lower limit means what? This is the value of x. If you put x is equal to 0, this value is what? The limit of the first term is 0, right? Then this is what? Sin 0 is 0. That means if you put the lower limit, your all the terms are 0. That means what here? We are not putting the lower limit because what? If you put the lower limit, then it is 0. So we put only the upper limit, right? So only the upper limit. This is what? Pi by 2 y plus y square, because sin pi by 2 is 1 now. Okay. So this is what? Dy. This is dy. Okay. So now note that you should have to put y the lower limit also, right? Check that is 0, right? If it is 0, there is no right. This is what? Minus 0 all this, right? So only put the upper limit there. Okay. Now we are integrating with respect to y now. We have to integrate this with respect to y. So this is what? Pi by 2 is as it is. Integration of y is y square by 2. Y square by 2 plus y cube by 3. So now this is what? Minus 3 to 3. Okay. So now this is equal to, I'll put first y is equal to 3 now. Okay. So put y is equal to 3. So this is what? 3 square. 3 square is 9. Right. 9 by 4. So okay, this is what? 9 pi by 4. 9 pi by 4. Then plus, this is what? 3 cube upon 3 means 3 square. 3 square means 9. 3 square means 9. Minus. Put x is equal to y is equal to minus 3. So become the square. Right. So minus 3 square is the what? 9. So plus 9 by 4. 9 pi by 4. Then this is what? Minus 3. So this is minus 3 cube is minus. Right. So minus 3 square. Square. So this is what? Minus 3 cube. Means what? This is minus is outside now here. So 3 cube. So that is 3 square. So this is minus 9. Or this is minus 27. Minus 27 by 3 is what? Minus 9. Minus 9. Okay. So now see here. 9 pi by 4 minus 9 pi by 4 get cancelled. 9 plus 9 is 18. So your answer is what? 18. Your answer is 18. Next, evaluate 0 to 1, 1 to 2. So no need to do. We will take simple. This is very simple. We already did this. Okay. So evaluate 1 to 3, 1 to 5, ln y upon xy, dy dx. Okay. Solution. Let r is equal to this. Now see here. What we have to do? We have to integrate with respect to y now. You have to integrate this with respect to y. Now see, this is log y upon y. Right? So log y upon y. So both are the functions of y. Right? So either you have to apply the by part. So this is what 1 by y into log y. 1 by y into log y. Right? So this is a product of two functions actually, 1 by y and log y. So note that. So for if there is a product, right? So we know that if there is a product, then we have to apply the by part rule, right? But when we have to apply the by part rule, so there is a product, right? But this is the last step of last thing. So don't apply by part everywhere now. If it is product, then don't try to apply the by part. So when we have to apply the by part, so if the substitution is not available, right, then and then only you have to apply the by part, right? So if substitution is available, then don't use by part now. So now this is what? Log y upon y. So if you put log y is equal to t, so 1 by y dy is there now here, right? So derivative of log y is 1 by y and 1 by y into dy, right? So that means what? Here the substitution is available, right? If substitution is available, don't apply by part now here, right? So don't think such way that what? If there is a product, then we need to apply the by part, right? This is the last weapon to apply the by part, right? हे शेवटचं शस्त्र आहे. कधी उठसूट आपल्याला प्रॉडक्ट दिसला की वापर बाय पार्ट असं करायचं नाही, राईट? वापर जर सबस्टिट्यूशन अवेलेबल नसेल तरच तुम्ही काय करायचं? बाय पार्ट वापरायचा आहे. So here what the substitution is available, if you put log y is equal to t, then 1 by y dy will be is there, right? So that means what here? We'll put t is equal to log y. Okay. So dt is equal to 1 by y dy. Dt is equal to 1 by y. Now see that these are we are converting this y in terms of t now. We are changing the variable now, right? So now these are the limits of y. So we will write the limits of t now here, right? So if y is equal to 1, this is y to power 1 to 5. So y is equal to, if y is equal to 1, then then t is equal to put what? So t is equal to what then? This is 0 because log 1 is 0. So this is what actually I have to take the ln y. So no, ln y is same as what? Ln y is same as log y actually. So base is e, right? So ln means log. Okay. So base is e now here. So if you see in chemistry, if they are writing log, then they are considering the base 10, right? So if the base is e, natural logarithm, then we are using the ln. Okay. So now the log 1 is always 0, right? With respect to any base, right? So ln of this is 0. So if now y is 5, so y is 5, then t is equal to ln 5. Okay. So ln 5. We will use ln now because what? So there is ln. So if there is log, right, log 5. Okay. So now we'll put this, right? R is equal to integration 1 to 3 as it is now. Now this is what these are the limits of y. So we have already get the limits of t now. So when y is equal to 1, t is 0. That means your row limit is 0. Your upper limit is what? Ln 5. Right? So 1 by x will be as it is now. Because what log ln y is your t now. And 1 by y dy is your dt and dx. So here what? You have to integrate with respect to this. Now here what? Here what? This is 1 by x and t. This is the product of two functions. Right? So I can directly write this as what? I can directly write this as what? 1 by 3, 1 by x dx. I can separate this because this is the product of the function. So t dt. I can directly write this. Right? So otherwise what? We have to integrate this with respect to t. You have to take 1 by x constant and then you have to write, right? So directly you can write this is what? So 1 by x is what? ln x now. Integration 1 by x is ln. So this is what? 1 by 3 into. So t square by 2. T square by 2. 0 to ln 5. Okay. So now this is what? ln 3. This is ln 3 because ln 1 is 1. Right? That means log 1 is 1. Log 1 is 0. So this is what then? This is what? ln 5 bracket square upon 2. Upon 2. If you put t is equal to 0, we get 0. This is your required answer. This is your required answer. Okay. Now this is very simple. You have to apply the substitution only here. Evaluate 0 to 1, 0 to 1, v u plus v square raised to 4 du dv. Okay. Solution. Let r is equal to this. Okay. Now what? You have to integrate this with respect to u now here. So now this is what is 0 to 1. Okay. I will integrate this. Your v will be as it is. Now this v square is constant. Right? That means this is a linear function. So you know that ax plus b to the power n, integration of this. Integration of ax plus b to the power n dx is equal to ax plus b as usual now. This is what? N plus 1 upon n plus 1 into coefficient of x. So coefficient of x is a now here. Right? So and the plus c is there. Right? This is the formula for the integration. Right? You are familiar with this one. Okay. So now this is also a linear function because b square is constant now here. Okay. So that means for the integration, this is what you are here. Coefficient of u is 1. So if coefficient of u is 1, then what? You have to increase the power and write the increased power at the denominator now. So just you have to write this what? U plus v square to the power 5 upon 5. Okay. So just this is integrated. Okay. 1 dv now. Now here lower limit is 0 now. If you put the lower limit, note that u is 0. But your all terms are not 0. That means you have to put the upper limit and lower limit also. Right? So 0 to 1. I write in curly bracket. Okay. So I put u is equal to 1 first. V into this is what? 1 plus v square raised to 5. Okay. No need to actually, this is the product. No need to apply. No need this curly bracket also. Okay. Write in one bracket now. Okay. So upon 5. Okay. Now we will put u is equal to 0. If you put u is equal to 0, this is the right hand minus. Okay, we are putting the lower limit term. U is equal to 0. Then v raised to 5 upon v square to the power 5 means v raised 10. So v raised to 11 by 5 now. Okay, now this is what dv. Now you have to integrate this dv. Okay, so now I can separate this integral. So this is what 0 to 1 v 1 plus v square raised to 5 upon 5. Okay, so dv minus 0 to 1 v raised to 11 5 dv, right? Just solve the integration, right, up to your knowledge now, right? If you are not integrated, if you are not able to integrate this, keep as it is, just integrate this one. It is your correct step. Okay, so that we will get the marks. Okay, now here what we have to do, this 1 by 5 is, you can take 1 by 5 here also. So this is what v, this is the product, now this is no problem here, directly we can integrate this one. You have to think only on this one, right? Now this is what 1 plus v square. Now see which one is the complicated. This 1 plus v square to the power 5 is the complicated here, right? So in integration, just check which one is the complicated and put that complicated as a single variable t. Your complicated part is what 1 plus v square. So I will put 1 plus v square is t now. If I put 1 plus v square is equal to t, so check the derivative of this. This is what dt is equal to twice v dv now. Now see v dv, you can adjust the two. Your v dv is here, right? That means here the substitution is available, right? If the substitution is available, then don't apply the by part now. No need to apply the by part now here, right? If you apply the by part, then the problem becomes so complicated now. That means if substitution is available, then also you are using the by part, then problem becomes so complicated now. So you check yourself. This is what problem becomes so complicated. We do not get the integration with the help of the by part also. Okay, so that means because here the substitution is available. So I will put 1 plus v square as 1 plus v square as a t now here. So okay, so I saw this one. Put t is equal to 1 plus dt is equal to twice. What is this? Dt is equal to v dv. Now these are the limits of v now. I will find the limits of t now. V is equal to 0 implies that t is equal to okay. So I put v is equal to 0. So t is equal to 1 now, right? T is equal to 1. When v is equal to 1, implies that t is equal to what? V is equal to 1. So this is 2 now. Okay. So therefore I is equal to 0 to 1. So 1 to 2. 1 to 2. So this is 1 by 5 is there now. So this is what t raised to 5 upon 5 will be as it is, because 1 plus v square is your t now. So t raised to 5. Now this you have to put the value of v dv. So v dv is what? 1 by 2 dt. 1 by 2 dt minus. So here what you can integrate this directly. This is what v to the power 12 upon 16. This is what 0 to 1. Here what? No need to change the limit, because what? Here this is the independent. Okay. So now we will integrate this now. So this is what? T raised to 6. T raised to 6 upon 16. This is what? 1 to 2 minus. Okay. If you put v is equal to 0, I can directly write the value of that one. So v is equal to 0, then this is 0. 1 by 16. 1 by 16. Okay. So this is what? Then 2 raised to 6. 2 raised to 6 upon 16 minus 1 upon 16 minus 1 upon 60 minus 1 upon 60. So this is equal to what? 2 raised to 6. 2 raised to 6 is what? So 2 raised to 3 into 2 raised to 3. 8 into 8 is 64. Okay. So 64 upon 60 minus 2 upon 60 minus 2 upon 60. So this is what? 62 upon 60. 62 upon 60. Right? So 62 upon 60, you may divide this by what? Because all are even number. So this is what? 31 upon 30. Don't cancel 3 now here. Okay. Next, evaluate integration of 0 to 1 0 to 3 e raised to x plus 3y dx dy. Okay, so let I is equal to this. So this is equal to what you have to. So this is e raised to x into e raised to 3y. I can write this as what? 0 to 1, 0 to 3, e raised to x into e raised to 3y. This is my dx dy. Now see, this is the product of two functions. Separately function explicitly function of x and function of y. Right? So I can, that means this is the product of function of x and function of y. And these limits are constant also. Right? These limits are constant. So I can directly separate the integration also. This is what? 0 to 1. These are what? These are the limits of x now. And the y last, that means these 0 to 1 are the limits of y now. So I have to take this function as y now here. dy. Then 0 to 3 e raised to x dx now. Okay. So I directly integrate this one. E raised to 3y is what? E raised to 3y upon 3. So 0 to 1 into e raised to x upon 1. That is what? No need to write it. Integration of e raised to x is e raised to x. So this is 0 to 3. Okay. So I put now here e raised to 0 is 1. Note that. So this is what? E cube upon 3 minus. If you put y is equal to 0, then this is 1 by 3. E raised to 0 is 1 into. So e raised to 3 minus 1. E raised to 3 minus 1. So this is nothing but what? This is e raised to 3 and this is e raised to 3 minus 1. So that means what? E raised to 3 minus 1 square upon 3. I can write this. Right? If you are not able to write this, then don't write this. Keep this as it is now. Okay? So if you are not able to, right? But you should be able to write this is what? E cube minus 1. This is e cube minus 1. This is what? E cube minus 1 upon 3. This is e cube minus 1. So a upon 3 into a. So that is what? A square upon 3. Okay? Next, evaluate 0 to 1, 0 to 3, xy root of x square plus y square dy dx. Now see here, this is not a product of the function of x and y, so you cannot separate this. Okay, so let I is equal to this. Now what here? This is the root. You know the integration of, see, this root x square plus y square is complicated now. Root of x square plus y square is complicated here. So what I do? So which one part is x square plus y square is complicated? Now we are integrating with respect to y now here. That means your x is constant. Right? And now this y is there now. This is the product of two functions of y now. This is y into x square plus y square. That means this is the function of y. Right? So that means what? Y and function of y, and we are integrating with respect to y. That means there is a product. There is the product of function of y now. Two function of y. This is y into root of x square plus y square. This is the product of functions of y. So you have to, don't think on the pi part now here. Right? First think whether the substitution is available. Now see, if you put, you know the integration of root x actually. You know the integration of root x. How to integrate root x? So root x means x to the power half. So that means what? In integration we are increasing the power. So this is what? X to the power 3 by 2 upon 3 by 2. That means you know the integration of root x now. So that means if I put x square plus y square as a t, x square plus what? Here put x square plus, we will check whether this substitution is available or not. So what we get then? We are differentiating this. This is what? Twice y dy. Now see, y dy is there. You can manage the constant. So twice y dy is equal to dt, right? So this is what? Twice y dy is equal to t, because we are differentiating with respect to y now here. Right? So that means what? Your x is constant here. Okay. So twice y dy is equal to dt. So y dy is equal to 1/2 dt. Okay. We'll change the limit also. Okay. So if y is equal to 0, then t is equal to x square. Then your t is x square. Okay. So if y is equal to 3, then t is equal to x square plus 9. Whatever this, don't worry about this one. Limits are this. Okay. So limits are variable. Okay. No problem. Okay. So now this I is equal to 0 to 1. So x will be as it is. Your y dy will be there. So x root t now. This is what? Root t. Because x square plus y square this. Now y dy is what? 1/2 dt. So into 1/2 dt. Oh, I have to put the limit here. Okay. So I have to put the limit. So what? I is equal to 0 to 1. Now when your y is 0, this is what? X square plus 9 x. Now this is what? Root t. This is root t. This is root t into half dt and dx. Okay. So this is equal to 0 to 1. Then this is what? X square plus 9. X by 2 will be as it is now. X by 2 will be as it is. Okay. Now root t is what? T to the power 3 by 2 upon 3 by 2 dx now here. We are integrating. Okay. So we are integrating. That means also we don't need this also. Okay. So directly we write this x will be as it is. Right. X by 2 will be as it is. T raised to 3 by 2 upon 3 by 2. Okay. So this is what? X square plus 9 and this is your dx. Okay. So now this is what? This is 3 by 2 is 2 by 3 and then 2 get cancelled, then this is what? 0 to 1. 0 to 1. Okay. So this is what? Just I will simplify this and then I will put the limit. This is what? X by 3 t root 2 actually. Okay. So I will write this is what? T raised to 3 by 2. T raised to 3 by 2. So this is what? X square plus 9 dx. Okay. Now we'll put the upper limit and we'll put the lower limit now. We'll put the upper limit 0 to 1. So this is what? So no need to the curly bracket is no need. So this is what? X by 3. So this is what? X square plus 9 to the power 3 by 2 minus x by 3. This is what? X square to the power 3 by 2 dx. Now this term will be simplified. This is what? X square to the power 3 by 2. So this is power to the power power to the power. So it is the product of the power. So 2 into 3 by 2. 2 into 3 by 2 is 3 now. X cube, right? This will be x cube and x raised to 4 now. So this I can separate the integral also. 0 to 1 x by 3 x by 3 x square plus 9 to the power 3 by 2 dx minus, I will separate the integration, minus 0 to 1 this is x cube, so x to the power 4 by 3 x to the power 4 by 3 dx. For this integral you don't have any problem. Okay, directly you can integrate this. Now this is what? X square plus 9 to the power 3 by 2 x square plus, now this is very complicated term now here, right? X square plus 9 to the power 3 by 2 is complicated now here. So now, and this is the product of two functions now. This is the product of two functions, right? So now check whether the substitution is available or not. Yes, sir. If you put x square plus 9 is equal to t, what is the derivative? That is twice x, right? Twice x dx. Now see, x dx is there. That means the substitution is available, right? Always give the substitution to the bracket. Always give the substitution to the whatever the term inside the bracket. Whatever the inside term. So this is what? X square plus 9. Try to give the substitution to that term x square plus 9. Right? Check, find its derivative. So now see the x and this is what? Whatever the derivative into dx is there or not. Right? It is a product with the help of with dx. Right? Derivative of that term of the whatever the term inside the bracket. Right? So and dx will be together now here. See. So derivative of this is what? Twice x. Right? Twice x dx. Right? You can manage 2 here. You can divide and multiply by 2. You can get it 2. You can manage the constant. Don't worry about the constant. Right? Now the x dx is there now. X dx. See x dx. Right? Product of x and dx is there. That means what? Here the substitution is available. So we can apply the substitution here. For there no problem. You can directly integrate that one. Okay. So I will put here what? So I write here I. Okay. So put t is equal to x square plus 9. So dt is equal to twice x dx. You don't have to. So I write this is what? 1 by t x dx. Otherwise you can manage this is what? Twice x dx. Okay. So now if if these are the limits of x, you want the limits of t. Now note that now this problem is what the substitution from this what this t and this t are different now here, right? You can take here what you can take any variable, you can take u, you can take t, you can take y also here, no problem for here. Okay, so I can take t here, but so that t and that t is here different now. Okay, so dx if now your x is 0, if x is equal to 0, then t is equal to, if you put x is equal to 0 here, then t is equal to 9. So if x is equal to then 1, then t is equal to, put x is equal to 1 here, then t is equal to 10 now. Okay, so now I is equal to 0 to 1. So 1 by 3 is there now, this 1 by 3, x dx will be there. So this is what, t to the power 3 by 2, 3 to the power 3 by 2. Then dx, x dx, what is the value of x dx? X dx is 1 half dt, so 1 half dt. Okay, now not this is not 1, this is what 10 to 9 now, or 9 to 10, this is 9 to 10, this is 9 to 10. Okay, now this is what integration, we will directly take the integration. This is 1 by 6, t to the power, add 1, now this is what 5 by 2 upon 5 by 2, so this is what 9 to 10, 9 to 10. Okay, so 9 to 10, now check. Put the value, t is equal to 10 now. So this is what, if you put t is equal to 10 now, what happened then? So this is 2 by, so 15, 1 by 15, 1 by 15, 10 raised to 5 by 2, minus 1 by 15, 1 by 15. Now see, 9 raised to, 9 is 3 square, 3 raised to 5. So this is what, 3 raised to 5. Okay, now this will be your answer. This will be your answer. Oh, and this term is remains now here. What? This is what? X to the power 5 upon 15, x to the power 15, 0 to 1, minus 1 upon 15. Okay, so minus 1 upon 15 is there, minus 1 upon 15. Okay, so here what, 3 raised to 5, you can simplify this, 3 raised to 5 by 9, so that means what, this is 1 by 15, 10 raised to 5 by 2, minus, so this is what, 3 square, so this is 9. How we get 1 by 15 actually? This is 1 by 15, not 1 by this, this is 1 by 15. Okay, 1 by 15 is there. Okay, and 9 raised to this is 3 raised to 5. 9 is what, 3 square, so square root 3 raised to 5. Okay, so 3 raised to 5 upon, so 1 by 15, 3 raised to 5, so 3 raised to 5 minus 1 by 15. This will be your answer. This will be your answer. Okay. We'll take one more problem. So 0 to 2, 0 to 2, 0 to pi, 0 to pi r sin square theta d theta dr now, d theta dr. Now see here, this is r sin square theta d theta dr, r into sin square theta. This is the product of two separate ones. This is the product of two separate functions. This is r into sin square. I can separate this. See, this is theta. That means these limits are theta. So I can write this is 0 to 2 r, 0 to pi sin square theta. d theta, right? This is dr. So now I will integrate this. This is what? R square by 2, 0 to 2. Now here what? 0 to pi. Directly sin square theta is not integration, is not integrable. So you know that where is the sin square? In the formula for cos 2 theta, there is the sin square. Is what? 1 minus 2 sin square theta. 1 minus 2 sin square theta. So that means what? I will shift 2 sin square theta. So this is what? 2 sin square theta. I also know the formula for 2 sin square theta is 7 what? 1 minus cos 2 theta. So sin square theta is nothing but what? 1 minus cos 1 half cos 2 theta upon 2 d theta, right? This is the value of the sin square theta. So that now this is integrable. Similarly, you have to write cos square theta is there. If cos square theta is there, then this is what? 1 plus 2 cos square theta is 1 plus cos 2 theta. You can see you will only have to write plus sign over here. So this is what? R square by 2. So if you put 0 here, so this is 2 now. This will what? 2 into. So I integrate this what? Theta by 2 minus sin 2 theta. Integration of cos theta is sin theta. Okay. So cos theta upon 4 now here. Then 0 to pi. Okay. So if you put pi, so sin 2 pi is 0. Right. If you put lower limit is 0, then this is 0. Sin 0 is also 0. Right. So no need to put the lower limit. We'll put the upper limit only. So this is 2. So this is what? 2 into. So 2 pi 4. So sin 2 pi by 4 is 0 now. Because sin 2 pi, sin n pi, sin 3 pi. Sin n pi is always 0. Sin 1 pi, sin 2 pi, sin 3 pi all are 0. So this is the second term is 0. Only this is what? Pi by 2. Right? So 2 into 2, this is what? Pi. This is the only answer. Okay. So I hope that you understand this, how to integrate. This is just as usual integration. Only what here is double integration. You have to take the care of the order of the dx and dy. Right? That order is very important. Right? Okay. So I hope that you understand all these things. Right? I will stop here.